Hello and welcome. Today we will be talking about what is a light-dependent resistor, LDR, how to connect one to an Arduino board, and explain the code for a simple LDR code. An LDR, or light-dependent resistor, is an electronic component that changes its resistance based on the amount of light it's exposed to. It's also commonly known as a photoresistor or photocell. Inside an LDR, there is a thin layer of this semiconductor material, which is typically sandwiched between two metal electrodes. When light strikes the semiconductor, photons are absorbed, and electrons are excited. When LDRs are exposed to bright light, the resistance of an LDR decreases, allowing more current to flow through it. Conversely, when it's in the dark, the resistance of an LDR increases, reducing the amount of current that flows through it. LDRs are commonly used in a variety of applications such as light sensors in cameras, solar panels, burglar alarms, automatic headlights, and agricultural automation. Their main function is to detect and measure light levels automatically and precisely in various devices and systems. Let's take a closer look at how an LDR can be used to control an LED. For this connection you will need 1 Arduino Uno R3 microcontroller, 1 photoresistor, 1 red LED, 1 10k ohm resistor, 1 220 ohm resistor. Here, we can see that the first terminal of the LDR is connected to 5 volts, and the second terminal is connected to the analog input pin, A0. There is also a 10k ohm resistor connected to the second terminal of the LDR. The other end of the 10k ohm resistor is connected to ground and the cathode of the LED. The anode of the LED is connected to a 220 ohm resistor which is connected to digital input pin, 3. After you have connected the components, you will need a code to run it. Here is an example code you can use for this circuit. The first box shows an Arduino code snippet that defines some variables and sets up the pins for a light sensor and an LED. Here's a breakdown of what each line does. Constant light _sensor pin equals A0. This line defines a constant integer variable called light _sensor pin and sets it equal to the value of the analog pin A0, which is the pin that the light sensor is connected to. This pin will be used later to read the analog voltage output of the light sensor. Constant LED pin equals 3. This line defines a constant integer variable called LED pin and sets it equal to the value of pin 3, which is the pin that the LED is connected to. This pin will be used later to send a digital signal to the LED to turn it on or off. In analog value, this line declares an integer variable called analog value without initializing it. This variable will be used later to store the analog voltage value read from the light sensor. Void setup. This line marks the beginning of the setup function, which is a special function that is called once at the beginning of the program to set up the Arduino board. Pin mode LED pin, output. This line sets the pin mode of the LED pin to output mode, which means that the pin will be used to send a digital signal to the LED. The second box, it shows the loop function of the Arduino code, which is a special function that is called repeatedly after the setup function has finished executing. Here's a breakdown of what each line in this function does. Analog value equals analog read light _sensor pin. This line reads the analog voltage value from the light sensor, which is connected to the pin specified by the light _sensor pin variable, and stores the value in the analog value variable. If analog value less than 500, this line checks if the analog value is less than 500. This threshold value can be adjusted based on the specific light sensor being used and the lighting conditions in the environment. Digital write LED pin, high. If the analog value is less than 500, then this line sets the digital output of the LED pin specified by LED pin to high, which turns on the LED. Else, if the analog value is greater than or equal to 500, then this line executes the following line of code instead. Digital write LED pin, low. This line sets the digital output of the LED pin specified by LED pin to low, which turns off the LED. In summary, this code sets up an Arduino circuit that controls an LED based on the ambient light level detected by a light-dependent resistor. Thanks for watching.